Scott's Geography Notebook. Do you want to try saying it?
Da, da, da.
So the two colors that we see more than anything else in the sky, we got to talk about how those get there. Blue skies and white clouds, and then there's the haze and the other things like that we'll talk about in just a moment. So let's talk about our blue skies first. So we know that coming from the sun, we have, and again, I'm going to use black, even though, yeah, I know, it's going to be white. All right, so we're going to have our white light. Okay, and this is our visual light, right? We know that within that white light that we have the whole color spectrum, right? And in another discussion, we talked about how the white light is that mixture of everything. Good. So all of that is there, but one of the wavelengths of light that's through there is going to be blue. Blue's part of it, okay, with everything else. Okay? And so we have the white light coming through, but in the atmosphere, we're going to have two different gases. And those two different gases I'm going to do are kind of small. We'll do one there and one there. And that's going to be two oxygen molecules. And so that's going to be O2. Okay? And then nitrogen, I forget whether nitrogen is bigger or smaller. And nitrogen is going to be N2. It's going to be there as well. Right? Now, all of the white light is coming through and hitting these molecules, but oxygen and nitrogen is going to scatter. It's going to choose, okay, it doesn't actually have any choice to the matter, but it is going to be selective. It gets to do some selective scattering, okay? And what it's going to do is it's going to take all of the light, but the blue, it's going to send out in all different directions. Now, some of the blue. It's not taking the oxygen, and the nitrogen isn't blocking everything. Otherwise, down on the surface, we wouldn't see anything blue. So oxygen and nitrogen are going to be selectively scattering these two colors. So we would say that our oxygen and our nitrogen are selective selective scatterers. And when we are just talking about the atmosphere, when we're talking about this particular scattering right here, it's named after someone named Rayleigh, or Rayleigh. Oh, sort of like sun's rays. Okay, Rayleigh scattering. Okay, now we come down here onto the ground and we're looking up into the sky. What do we see? Well, we see the regular white light coming in, sure. Along with that, there's going to be some blue, okay? But we're also going to see where the light gets scattered from the oxygen and the nitrogen. Oxygen and nitrogen, pretty cool for what they do. They're going to be scattering just those. If they were different gases in the atmosphere, would it cause a different color? It would. We see that on other planets. I think Mars has different colors coming in. The sky looks a different color because of the types of gases. Oxygen and nitrogen are going to make our sky look blue. Now, what do we know about the white clouds that we have going on? All right, well, let's get away from that and remember that our particles are going to be a little bit bigger at that point, right? So we're going to have the white light coming in. And we're kind of going to the opposite side where the size of our particles are going to be very, very small when we're looking at oxygen and nitrogen molecules. Here we're looking at water droplets. This is going to be not just water as a gas. It isn't just a little H2O. It is an entire water droplet. Okay. Water droplet in terms of size, totally opposite side of the spectrum. It's going to be changing everything around. Now, what happens with the white light that comes in, it's not going to be selective this time. And so what's going to happen is it's going to take that light and boom, 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 is sending that white light in all different directions. Okay. So again, when we're back down here on the ground, and we look up and we see that water droplet or a big accumulation of water droplets. That is a cloud. Oh, look, we got silver. We're going to do silver clouds. Good. When we see those clouds up in the sky, that's going to be the diffusion. So the light comes in, and it doesn't block all of the white light, but what it does is that first water droplet is going to send it this way, and then it's sending it this way, and then it's sending it this way, and it's finally coming down. Right. Now, this cloud continues to get thicker and thicker, right? Maybe it's going to be growing vertically. It's growing thicker and thicker. Or the droplets down here at the bottom are going to be getting bigger and bigger. And what will that start to do to that cloud? Well, it's going to start to give us some grays in the bottom of the cloud. Okay. So when we see the bottom of the cloud that's grayish or getting darker and darker, that's just indicating to us that the white light that's coming to the top of the cloud, it's going to bump around a lot because of the thickness of the cloud, or those droplets along the bottom, it's just about to rain and it's getting much, much thicker. All right, let me show you some pictures. All right, the first picture I want to show you is from up in the Sierras. And this particular picture is going to be, the reason I wanted to bring this one up is the color of that blue up at the top. That is a dark, dark blue. And this is what we see when we go higher up into the Sierras, or we'll see this oftentimes right after a rain. Okay? Everything gets cleaned out of the atmosphere, or when we go up to the mountains, there's actually less atmosphere there. And as oftentimes the air is drier, there's going to be less humidity in the air, and so we're going to see a darker blue color. And of course, the beautiful clouds that are there, we see some that actually look like they have the gray along the bottom. I want to show you one other picture. This is also up in the Sierras. The clouds aren't all that spectacular in this, and we do see that white haze along the horizon. We can talk about that in just a moment, but notice that mountain that's way off there in the distance. It almost has a bluish color. Okay? That is the Rayleigh scattering that we see between the camera and that mountain. So it isn't just the blue skies. Artists have learned that when you want things to look in the distance, landscape painters, you kind of add a blue color to there. Okay? Now, it isn't always just a cloud that we start to see. Right? What we're going to start to see as well is any type of water that we have in the atmosphere. And oftentimes it's going to be either water, or it's going to be dust particles, or it's going to be dust particles that become that condensation nuclei. And if we're looking along the horizon, what we might see is all of the water droplets or humidity. I don't want to say humidity because the gas itself, the water molecules as a gas, not as much of this diffusion. But once we get a little bit of condensation going on in there, or we have a lot of dust particles, or we have a lot of salt particles, then what we start to see is, again, some of that diffusion from those items. So the whole rest of the sky is going to be blue from the O2 and the N2, nitrogen and oxygen there. However, oftentimes along the horizon, a lot of times in the Central Valley, in the summer, when we haven't had rain for a long time, the air isn't all that clean, we start to see some of this haze along the horizon. It's the same thing. It's the white light coming down, and because there's more material down here, it's going to be causing more diffusion. Okay, back to the pictures. This is a picture looking from Santa Barbara out over the ocean. This is actually near UC Santa Barbara, looking down the coast towards Santa Barbara. And you can see that right along the horizon, it's white. And then it gradually fades up to the blue. Okay? That's because right along the horizon, there's going to be more yuck there. All right. One other picture of clouds that I wanted to show you is this guy here. You can see that much cloudier, much more stormy looking, much more daunting. We are looking through the car window, and so that causes some of the haze that we have. However, those clouds that are there right above those mountains there in Utah, those clouds are very, very dark along the bottom, probably because the size of the water droplets are increasing, blocking and scattering much more of the light coming through. Okay, so we've talked a little bit about the blue skies and the white skies, why we have those different influences. Another few pictures here Hawaii, right along the water, we see that haze kind of coming up off there. That could be salt particles, or it could be water droplets that have kind of been scattered up. Niagara Falls, right there at the falls. If you ever go there, go down onto the river below the falls. Very, very misty, and everything is looking white. Just a part of the beauty that we have from oxygen and nitrogen and particulates in the air.